Okay, first thing that we want to cover here together is an understanding of how to convert back and forth between inches and millimeters, because this is a big part of our fraction lessons. So as indicated on the lesson plan, what I made mention of there was that if you want to convert a measurement from millimeters to inches, then you have to divide by 25.4. And so 25.4 is the number that we use for converting back and forth between inches and millimeters. Basically what that is there are 25.4 millimeters in 1 inch. Okay, so this is what this is based on. Okay, so if I had, for instance, I took a measurement or I answered a question on a test and the final answer was 200 millimeters, but the question says once you have your answer, convert it into inches. So 200 millimeters, what is that in inches? So basically all we're going to do is take 200 and we're going to divide by 25.4. We'll pull up our calculator. 200 divide by 25.4. And that gives us 7.874 inches. So notice in this question I didn't say anything about how many decimal places, but because I didn't say anything, you automatically will round to 3 decimal places. The inverse is true. If you had, let's say, 1.323 inches, and I asked you to convert that into metric or into millimeters, then you would say 1.323 inches times 25.4. So 1.323 times 25.4 is 33.6042. 33.6042. We know that the rule of thumb from metric is that you would round to 2 decimal places unless told otherwise. So therefore our answer is going to be 33.60 millimeters. Okay. This is important, especially, I mean, if you're not going to continue as a machinist, that's okay. We'd prefer to see that you do. If you do, you're going to be converting like this every single day. Dimensions, metric to imperial and imperial to metric. Does anybody have any questions about this piece of it so far? I know it's pretty self-explanatory, but I don't want to create an environment or have an environment with you people where you don't feel free to jump in and ask questions. So if I get ahead too far, or if I explain something you don't understand, please, you don't need to put your digital hands up. Just turn your mic on and interrupt. I'm completely okay with that. Okay, so if nobody has any issues with this, I will move on. Okay, the next piece on our lesson plan here is, let's see, common fractions. Okay, good. All right. Let's just quickly, to make sure that we're all on the same page, let's just do a couple of examples of converting common fractions to decimal fractions, and then we'll do the inverse. But for anyone who doesn't remember, I'm just going to write these, write the examples of the fractions we're going to be talking about. So if we just take a simple common fraction, 1 over 2 is a common fraction, right? Common fraction, obviously your numerator is smaller than your denominator, right? So is smaller and your denominator is greater. And basically that works on the, the basic principle of fractions. This circle, let's call it a pi. Everybody likes pi. This, I hope, this pi represents the whole piece, right? It's the whole pi. In math, we talk about units. So this is the entire unit, whatever that may be. As soon as we divide this in half, this is still the whole unit, but I just want to know how much of the whole unit is this, right? This side. So it's one of two pieces. This is the whole unit, but this is now one of two, right? There's now two pieces. So that's how we would write this common fraction. So we also have an improper fraction. Okay, so the improper fraction, the inverse is true here. The numerator is greater than the denominator, right? So for anyone who's interested, an improper fraction, if you don't already know that, any number on the number line that we use, so 1, 2, 3, 4, 49, 77, 8,000, those whole numbers, in math, the number 47, say for instance, is understood as 47 over 1. So remember that, because we're going to, when we get into ratios and proportions, we will be coming back to this. So any whole number, whatever that number is, doesn't matter what number it is, any whole number is thought of in math as written over a 1. Okay, so don't worry about any of the reasons or anything right now, but if you can just remember that, an improper fraction is just a whole number written over 1. And then of course we have our mixed number. Now our mixed number, going back to our pi example, our mixed number is basically saying this. This is the whole unit. Here's another whole unit. Okay, so this would be represented by this, and this would be something referring to here. Well, we know what it means. We know it's one side. So we have two whole units, but in our mixed number, we have one whole unit, and then we have half of the other whole unit. And that's what the mixed number is. So this number, if you want to go back to improper fractions, is actually 1 over 1 and 1/2, right? Just keep it in your mind. Just always remember whole numbers are written over a 1. Now I'm not going to expect you to do that for our questions. That'll get you confused until we get to ratios and proportions, but I just want you to be aware of that. Okay, so these are the three types of fractions we're going to be talking about, other than what we've already touched on, 0.500. This is also a fraction, but it is our decimal fraction. Okay, so keep these in mind, because we will be referring to these 4 different types of fractions. We're going to just go over a couple of examples right now of how to convert back and forth between common fractions and decimal fractions, and then the inverse. So if we took, for example, we'll use the, let's see here, let's use the, let's go 5/8. Okay, so if we take 5 over 8, and we want to convert that into a decimal fraction. The nice thing about the math that we get to do is we get to use our calculators as often as we want. When you're converting a common fraction into a decimal fraction, all you need to know is that this line here, so this is your numerator, this is your denominator, this is a dividing symbol. So 5/8 can be written like this. It can also be written like this, like this, or like this. So this common fraction, 5/8, is understood to be 5 divided by 8, right? 5 divided by 8, 5 divided by 8. Now, in case you didn't know, a ratio, this symbol 2 is also understood to be a dividing. Let me just get rid of this part as dividing. So let's go back here. So 5 to 8. Okay, so maybe if you've been in any type of trade where you've worked with prints, maybe a construction print, maybe you've seen something like this, the drawing scale, you might have seen a 1 to 2 scale. All that means is it's half scale. It's drawn to half the scale that it truly will be manufactured to. So that's all this is. A ratio is just dividing. So when we're trying to solve 5/8 and convert it into a decimal, then we just take 5, and 5 divided by 8 equals 0.625, so 0.625, and convenient for us, if this were in inches, we'd already be rounded to 3 decimal places. So any work that you guys do that takes common fractions, mixed numbers, improper fractions, and asks you to answer them in decimal fractions, if you're not using a calculator, you're working way too hard. And so please make sure that you don't work more than you need to, because we'll have enough on our plates. If your question on a test said convert all fractions to decimal fractions, all dimensions are in millimeters, make sure that this answer would be 0.63 millimeters, right? So, and that's what we want to touch on next, is the rounding part of this. Any questions so far? Okay. All right. So the proper rounding part, let's go to that. So let's take 0.74028934. Just take some obscure number. You will guaranteed, on our assignment tonight, on your assignment next week, and on your test the following week, you will most definitely get questions where you're told to take a number and to round, you'll have in brackets beside it, round to whatever number of decimal places. So let's say 4 decimal places. So at the college level, it's amazing how I've met so many students who struggle with how to round properly. So I'm going to go through this with you, and if you ever get confused, go back and watch this portion of the video. This is important. If you're asked to round to 4 decimals, 1, 2, 3, 4, then all you care about is 5 decimal places to start. Doesn't matter how long the number is. If you've been asked to round a number, an existing number, to, let's say, for instance, 4 decimals, then all you care about is looking at 5 decimals. So anything beyond the 5th decimal place, you can just scratch out. No one cares what it is. It will never be brought up again. It's gone. So I want to rewrite this number, this 5 decimal place number, to 4 decimal places. The 5th decimal place, the reason that we hang on to that one, again, for those that don't know, so bear with me if this is old hat to you. The 5th decimal place tells you what to do with the 4th decimal place. You know, if we could take any number and just say, just round it to 4 decimals and there were no rules, then the answer here would be 0.7402, right? There's 4 numbers. I'll just scratch that out and leave 4 numbers. But especially when it comes to the machining world, what I'm about to show you is normal rounding. This is what's expected. But in the machining world, improper rounding can lead to scrap parts. Scrap parts leads to lost jobs. So we don't want to go there. So the rule here is that if I want to round this to 4 decimals, I'm going to look to the 5th. What is this number? If it's a 5, 6, 7, 8, or 9, then that tells me that this number has to, the 2 has to increase by 1. So any number above 5 here will make this number into a 3. Any number below 5, 4, 3, 2, 1, 0, then this number stays the same. So if I take this gigantic number and I see over here 4 decimal places, I'm going to get rid of any confusion. And I'm going to go 1, 2, 3, 4. Okay, 4 decimal places. I need 1 more, 5. I'm going to scratch out everything else. I don't even want to look at it. Now I look to the 5th. All right, if this is a 5 or up, then this number goes up 1. And that's our case here. 7.7403. Okay, so that would be the answer to this question, right? 0.7403. Now, if we took 0.4329169, and we said round to 2 decimals. 1, 2. All I care about is the 3rd decimal place. Anything before that is garbage. Don't care about it. I don't even care what the number was. And this is the problem that I found with students. If we were to, and I've seen this before, I've seen students say, okay, so round to 2 decimals. So I need the 3rd decimal, but this is a 9. So this I would round up, and that would become a 3. And no, we don't start here and round all the way back. If it's rounding to 2 decimals, I only need to look at 3. Everything else is non-existent. We don't care what it is. We're never going to look at it again. This number here tells me what to do with this number. If this is a 5 or up, this number goes down, goes up. If this is a 4 or down, this number stays the same. So therefore, this number becomes 0.43. Because this is a 2, it's less than 5. This number stays the same, and we've rounded to 2 decimals. Now, I don't know what the reason is. I do know that this, for some reason, rounding confuses people. Maybe it's just the relaying of information. But if you get confused by this in any way, or if I notice in any of your assignments that you're rounding improperly, I'm going to ask you about it, because I don't want to start taking marks off, bang, 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 bang. I understand that this sometimes is just a difficult concept. Whatever the reason is, I don't know. If it's not difficult for you, perfect. But if you can remember, no matter what the number is, I don't care how many decimal places it is. This is what I'm looking for. If I need to round to 4 decimal places, I only need to leave 5 here, and I can scratch out everything else. Mentally, I can scratch it. I don't have to scratch it on my paper, but you get the idea. So you'll see in tonight's assignment, you will get a series of questions where we round these numbers, and it'll tell you to the number of decimal places. Any questions on this part so far? No confusion? All right. I told you at 10 after that we don't have much left. We're just going to do the converting decimal fractions back to common fractions. Okay, so this is your opportunity. If you'd like, up to this point, is there anything here you'd like me to review or give another example of? Are we okay to move on? You can turn your mic on if you want me to do something as a refresher, or if you have any questions. If I don't hear anything, I'm just going to move on. Okay. On the lesson plan that I gave you guys this week, or sorry, this morning in your email, I gave you this example, 0.875. Now, this is a decimal fraction. I know you're aware of that. And if you have a scientific calculator with the change button, you can type in 0.875, enter, and then hit change, and it'll come up and it'll tell you the fraction. And that's great. However, when the time comes where you need to solve a decimal fraction or convert it into a common fraction, and you probably will get something, some of you will get that on your Red Seal exam. Knowing how to do it is very, very helpful. So here's the rule. If I want to take this decimal fraction and I want to convert it back into a common fraction, the first step is to rewrite the number without the decimal. Just write the numbers, right? So 8, 7, 5. And please excuse my handwriting because I'm using this digital whiteboard, and it's not like being at the front of a classroom. It'll get better over the weeks. If it doesn't, well, I'm sorry. Okay, so rewrite the number without the decimal. It is the numerator. Okay, it will become your numerator. There's no decimal in a common fraction. That's why we get rid of it. You're going to write that number over the number 1. Remember, we already talked about whole numbers are always written over a 1, right? Well, we're gonna write this over a 1 and as many zeros as are in the numerator. So it'll be decimal 875 rewritten as 875 over 1 with 3 zeros, 1 for each of the numbers in the numerator. So basically, we have taken this decimal fraction and we've converted it into a common fraction already. But for those of you who don't remember, we want to make sure that any time, even if you're not asked, you don't need to be asked on a question or an assignment or in the working world, you don't need to be asked to convert this number into the lowest terms. So this fraction is correct. 875 over 1,000 is 0.875. But it needs to be converted into its lowest terms. So how do we do that? How do we figure out what the lowest terms are? Well, if you looked at the assignment that I gave you, the instructions I gave you said, now reduce the fraction to lowest terms by finding a number that is divisible by the numerator and the denominator. Well, here's the thing, friends. 875 and 1,000, they're divisible by 5s, aren't they? Right? Both 5 and 10 are divisible by 5s. The problem is, how many times would you have to divide this by 5 and this by 5 to find the lowest terms? So there's no rule here. There's no simple answer to this. What you want to do is try and conceive the highest number you can think of that would be divisible into both 875 and 1,000. So I think the example I gave was 25. So 875 is divisible by 25 and 1,000 is divisible by 25. So if we get our calculators and we say 875 divided by 25, we get 35. So we'll just write that, 35, and then 1,000 and divided by 25, oops, is 40. So something interesting, we're kind of covering two lessons in one, because this will be repeated when we get into ratios and proportions. Remember we said that the common fraction is just dividing, right? Numerator divided by denominator. If we're trying to find the lowest terms here, and we find a divisor that fits into both of these, which we did, which is 25, and we end up with 35 over 40. What we're saying is 875 over 1,000 is equal to 35 over 40. And we know that's true because we divided the numerator by 25 and got 35. We divided the denominator by 25 and we got 40. So 875 over 1,000 being a fraction, we also learned it's a ratio, right? Now, this is how much of the whole unit, right? This is the whole unit. This is the piece of the whole unit. When you have a ratio or a common fraction and you say it equals another ratio, right? In this case, another common fraction, and they have to relate, right? And we know they do. This was divisible by 25. This was divisible by 25. Now you have two ratios, and when you put an equal sign between two ratios, you have a proportion. And when we get to our assignment on ratios and proportions, we're going to learn some neat little things about how we can find unknown portions of our ratios so that we can make the equal sign true. And we'll come back to that. But just, I want you to see how fractions threads through all of the math that we're going to be doing. So we're not at lowest terms yet. So what we could do is find another divisor, or what we need to do is find another divisor. We do know that 5 will divide into 35 and 40. So 5 goes into 35. We'll just do everything on the calculator so everybody can see. We take 35, and we divide it by 5, and we get 7. And then we take 40, and we divide it by 5, and we get 8. So therefore, 0.875 equals 7/8. Okay, so that's how we convert a decimal fraction back into a fraction. Just remember that this part of it here, friends, there's no rule. There isn't a shortcut. If you're just brilliant in math, you could probably do that in one step, no problem. And once you've been working in a machine shop for years, you'll look at certain decimal places and you'll know right away. 875, oh, that's 7/8, right? 625, that's 5/8. You start to just be familiar with them. But when you need to prove things, we want to make sure that you can prove them. Okay? All right, any confusion, any questions about the lesson for this week? I know it's mostly probably a review for some, but would anybody like to ask any questions or want anything repeated or shown?